Alright, it's time for today's lesson on tangents and secants. So previously we had dealt with chords and angles inside circles, all this stuff. If you have two chords crossing, then the product of these two is going to equal the product of these two. Things like that. You got this angle is the average of these two angles. Just a lot of different things like that. But today's focused on tangents and secants. So, quick recap. A tangent's a line that comes and hits your circle at exactly one spot. What this first sentence here is saying that if you're to draw the radius to this point of tangency, it's going to be a right angle every single time. So that's always going to make a right angle, which, by the way, you could then turn into a right triangle if you connected the B and A there. And then this other sentence saying the two segments from the same point outside the circle are tangent to the circle. Anyway, basically, if you have one shared point out here and you have two lines coming off, and they hit at a tangent point, then these two segments have to be congruent to each other. So they have to be the same length. So those are two features we're going to be using. And then you have these three statements here. So remember, a tangent comes and hits once. A secant is just a line that comes through and hits the circle twice. But if you have two secants coming off the same vertex here, you can find this angle measurement by taking this arc measure and this arc measure and subtracting them, and then times it by half or cut it in half. And the same is true for the other setups here. So if you have one line that comes out and hits at a tangent, and the other line comes and hits at a secant, if you take this arc measure and this arc measure, you subtract them and cut in half, you'll get this measurement here. And same for the end here. If it's two tangents this time, if you take this measurement and you subtract this measurement and cut in half, that'll be this angle here. So we're going to be using those 5 properties in today's assignment. We're just going to run through a few examples. So pull up tangents and secants now. And this first section here mainly deals with right triangles. Because remember, if AC, A to C here, is a tangent line, then that means this is a right angle. And if we know this distance and this distance, we could find this one through Pythagorean theorem, right? You do hypotenuse squared equals 12 squared plus BC squared, whatever the length of BC is. And so you can subtract off 12 squared, and you get 13 squared minus 12 squared equals BC squared. And then you can square root it and find out what the distance from B to C is. So pretty quick there, just Pythagorean theorem stuff. Let's go through a few of these and see if we can solve for an unknown. So let's look at B. Again, we have a right triangle because this is a tangent and B is the point of tangency. We're supposed to solve for this R length here. Well, we don't know the R length right now, but we still can use the Pythagorean theorem. This squared plus this squared equals this squared. And so this entire distance here is R plus 9. And so we are going to set up the equation. Got 15 squared plus R squared equals R plus 9 squared. This is something we've done before. It's just a binomial squared. So I'm going to write out this stuff here. R plus 9 squared is R plus 9 times R plus 9. This is why you don't want to forget all your solving quadratic stuff earlier. So we're going to distribute here twice. Distribute, 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 distribute. You get R squared plus 18R plus 81, and that's going to equal 15 squared plus R squared. You, again, want to make sure your R's are all by themselves and all your numbers are on the other side. So I'm going to subtract off R squared from both sides here because it's on both sides. And I'm going to also subtract off 81. I'm going to put all my numbers here on the left side. I don't know why I put 18, 81. So now on the right side, I have 18R. Left side, I need to do 15 squared minus 81. Wait, calculators are good at stuff like this because I don't want to have to memorize this. 225 minus 81 comes out to be 144. And it's just a matter of dividing by 18, and you get your R value. Divided by 18 comes out to be 8. Ta-da, we found the R value. We win. So yeah, that's just remembering that tangents hit a right angle, so it makes a right triangle, so you can do Pythagorean theorem to find your unknown. Let's jump to a few other examples. This is one's focusing on the angle stuff. So if you remember, this measurement is equal to these two measurements subtracted and then cut in half. So x degrees is going to equal 120 minus 54 degrees. Degrees, not squared. Cut in half. 120 minus 54 gives you 66. Cut in half. You're looking at 33 degrees. Ta-da! Solved. Easy peasy. You just have to remember the property, and you can set up your equation and solve it. Well, sometimes you don't have such nice setups where it's like, oh, I already know the two numbers, so I subtract and cut in half. Instead, you get things like this. Well, luckily, you can still set up your same sort of equation. So this measurement here, this arc measure is going to be x degrees. And it looks like these are tangents, and since they look like tangents, we're going to assume they are, which means they only hit at one point. So I got another measurement over here. Well, this part's x. This part over here, well, that's the rest of the circle. And circles have an arc measure of 360. So I can subtract off x, and that's the outside part. Well, that means this angle is equal to the big one minus the small one cut in half. And that makes an equation. So I'm going to go ahead and make the equation. 30 degrees, sorry, it's about 30 degrees equals 1/2 of 360 minus x. Put some extra parentheses here, and then minus x again. So this one minus this one, so 360 minus x, and then minus x is going to give me that. So let's do some simplifying here. Now I got 360 minus 2x. All right, minus x gives you minus 2x. I can cut both those in half and actually distribute. So I got 180 minus x equals 30. And then I can subtract off 180, which will give me, let's see, 30. 30 minus 180 gives me negative 150. And that gives me negative x. And so I can just, divide by negative 1 or times by negative 1. X is 150 degrees. Which, that's not too bad, right? It's a good section there. It's looking realistic. And so, ta-da, we got our x value. So sometimes the setup's really nice. You just plug the numbers in, cut in half. Sometimes you have to set up your own equation and solve for x. But that's pretty much it. That's what's going on. So if you look at your assignment, you got some right triangle solving to do. I know this doesn't really look tangent, but we're going to assume it's tangent. And so one of the properties we haven't used yet is that if you have two tangent segments coming off a common point, then they're congruent. So this is congruent to this, which means you can set this equal to this, and you can solve for x from there. Let's see, similar thing happening here. Let's see, what else? Just angle setup. So there you go. Should be pretty easy, not too bad. You just have to remember your properties as you go through these. So good luck. Be safe out there.